In this vodcast, we're going to look at some basic trigonometric properties that allow us to simplify trig expressions and do substitutions and various things that we'll like to do in the future. Uh, Here's this basic picture that we've been looking at. Here's a unit circle. I've got a reference triangle marked in there with a point UV on the terminal ray on the unit circle. We've talked before about since cosine is u over r and r is 1, then u and cosine theta are one and the same thing, and v over r is sine theta and r is 1, so v and sine theta are the same thing. These properties that are on the screen right now are ones that you're familiar with because we defined cosecant theta. We defined that to be the reciprocal of sine. We said that sine was v over r, and we defined cosecant to be r over v. Those are reciprocals. So there's many ways of looking at reciprocals. Oftentimes with fractions, if you say what's the reciprocal of 5, well, then you write 1 over 5. If you say what's the reciprocal of 2/3, then you write 3 over 2. Well, it's the same thing here. Another way of saying that is the cosecant of theta is equal to 1 over sine. That's the same as saying, well, this is really what reciprocal means, is the product of two things. If the product of two numbers is equal to 1, then they are reciprocals. That is the definition of reciprocal. So these are all nice reciprocal relationships. In fact, on your calculator, if you wanted to find the secant of 60 degrees, you would do 1 divided by the cosine of 60 degrees. That's how you find it. And you all know that the cosine of 60 degrees is 1/2, right? So this better come up to be 2. Yay, it does. I'm in the right mode. I'm in degree mode. And so that's how we actually calculate these secondary trig functions, cosecant, secant, and cotangent, because we do not have those buttons on our calculator. Okay, enough of that. So those are some basic, those are called reciprocal properties because they're based on reciprocals. Next, here's the same picture again, and in this picture, we've already defined tangent to be, we know that the tangent of theta in this picture is equal to v over u. Well, guess what v is? V is sine theta, and u is cosine theta. So this is called a quotient property. The quotient tangent theta is equal to sine theta over cosine theta. And here is kind of a using the reciprocal property. You notice in this relationship here, if the cosine moves across the fraction line and goes on top, then it becomes secant, becomes its reciprocal. And likewise with the sine goes to the bottom and becomes cosecant. So you can always switch things back and forth across a fraction line by changing it into its reciprocal. And down below, here is the cosine. Why can't I get rid of those things? Okay. Cotangent of theta is the reciprocal of tangent, so the quotient properties are all turned upside down. Cosine over sine is equal to cotangent theta. Cosecant over secant is also equal to cotangent. So you should be associating sine with v and cosine with u by this time. So it should be easy to remember these quotient properties as v over u, sine over cosine, and the cotangent would be the reciprocal of that. So kind of have to get all these things connected in your head. Moving on, here's the third important one, and this one we haven't talked, this one might not be as obvious, but it's really important. These are called Pythagorean properties. So in this picture, I've got a right triangle. I've got this right triangle, reference triangle here. And this is a unit circle, so r is equal to 1. But in general, I could say r u squared plus v squared is equal to r squared, but r squared in this particular case is equal to 1, so I'm going to replace that. And I've already mentioned that u and v are identical to cosine theta and sine theta, so by substitution I can say cosine theta squared, because that's u squared, plus sine theta squared is equal to 1. That is a Pythagorean property. That is the most basic. Now here's a little note. We don't usually write it in that form. It's customary to write cosine squared, like you put the squared over the function name. Rather, you can either write it with a parentheses, although most people do not, or you can write it like this. But don't put the squared on the angle, because you don't want to square theta and then take the cosine of it. That would mean something quite different. So here's a little note to yourself. Cosine squared theta means cosine theta squared. And I want to point out on your calculator how that is actually entered slightly different even than that. On your calculator, when you put in cosine 60, remember cosine of 60 is 1/2, square that. That's how you square it on, oops, don't want it twice. That's how you square it on your calculator, and I should get 1/4, which is 0.25. So that's the calculator notation for doing cosine squared theta. Okay, so we have this expression. Let me copy that down here. This is the first basic Pythagorean property. All right, there are two more that you need to know, and actually there's several versions of each one even. Like, for example, I can algebraically transform this into 1 minus cosine squared. Let me write this down. Algebraically, you should be able to see easily that sine squared theta is equal to 1 minus cosine squared theta by subtracting cosine squared from both sides, and likewise cosine squared theta is equal to 1 minus sine squared theta. So these are just those are just different versions of that one. But we can also do some other manipulation. What if I take this and divide everything by sine squared? Now let's do it by, I'll divide by cosine squared first. Divide everything, both sides, by cosine squared and distribute it across cosine squared theta and 1 over cosine squared theta. And we're going to use some of the properties we just talked about. Cosine squared over cosine squared, of course, is equal to 1, plus sine squared over cosine squared. Well, sine over cosine, quotient property, that's tangent squared. Tangent squared theta equals 1 over cosine squared. Hey, that's a reciprocal property. 1 over cosine is secant, so 1 over cosine squared is secant squared theta. So here is another Pythagorean property. And I can also subtract things. I can subtract 1 from both sides and get tangent squared equals secant squared minus 1. And those are useful manipulations of these things, algebraic manipulations of these things. But I can also, let's do this one more time. If I start with this again, and this time divide through by sine squared, what am I going to get? Sine squared theta here, sine squared theta there, sine squared theta, and cosine over sine is cotangent. That's another quotient property. So you see how those are coming in handy already. Sine squared over sine squared is 1 equals 1 over sine squared. That's another reciprocal property. That is cosecant squared theta. And let's just do one more thing on a calculator just to convince you maybe that these are all true. But so these are the three Pythagorean properties that you need to know or be able to come up with fairly quickly on your own. And like I said, there's these other variations. Here, let's look at one more thing on the calculator. I should be able to do cosine of some angle. Let's just choose some random angle. How about 42 degrees? 42 degrees squared plus sine of 42 degrees squared equals, hey, it equals 1. That's what the Pythagorean property is saying. They're called Pythagorean properties because they're based on u squared plus v squared equals r squared. Okay, we will do lots of problems based on these in class.